What if humanity just grew a new sense? Not a bigger eye, but a different one, able to feel the warmth of stars still wrapped in their birth clouds. And to recognize the oldest light as it drifts home, red and tired from a long journey. Stay with me. In the next few minutes, you'll see why a golden mirror, unfolded in deep space, lets us watch the universe's first mornings. Mornings that until now were only rumor in mathematics. Out there, far beyond the weather and the glow of our cities, a flower of gold opened petal by petal. Each segment clicked into place with the soft confidence of a heartbeat. Behind it, 5 vast sheets unfurled like a silver sail, thinner than paper and broader than a tennis court. Together, they made a shadow so perfect that the mirror could grow colder than the night around it. Cold is the price of this new sense. To feel warmth across the universe, you must first become quieter than space. Most of the light our eyes know is only a sliver. We live where rainbows end. On the red side, yet beyond that edge, the spectrum continues as invisible warmth. Infrared. Hot sand after sunset, the breath of a teacup, the soft glow of dust that hides newborn stars. To ordinary eyes, those dust clouds are curtains. In infrared, the curtains turn to lace. The nursery appears. There is another reason to look in this color of memory. As the universe expands, light from its earliest fires is pulled longer and longer, like a violin note slowed to a hum. What began as fierce blue starlight is stretched into deep red and beyond. If we want to see the first galaxies, we must follow that pull into infrared, where ancient brightness now rests. So we built a mirror that listens, not just looks. Each hexagon of gold is a tuned ear, catching whispers that have crossed 13 billion years of emptiness. That mirror sits far from Earth's warmth, always facing away from the sun, living in a constant eclipse. In that hush, it can notice what our species has never noticed before. And then, one image. A thumbnail of sky the size of a grain of sand held at arm's length. We point our new sense at that nothing, and it spills open, thousands of galaxies. Some so faint they seem like smudges of breath on glass. Some arced and stretched by gravity's lensing into delicate commas of light. Each is not a star, but a city of stars, built when the universe was young and restless. This is not just beauty, it's time travel with evidence stamps. By reading the color of those galaxies, we can tell how far their light has wandered. By tracing their shapes, we infer the invisible scaffolding of gravity that cradled them. By noticing their glow in infrared, we learn what dust they carry and what elements they forged. The first deep field is a census of beginnings. Of course, this mirror will do more than watch the first cities of stars. It will read the weather on worlds that circle other suns, clouds, heat, perhaps the breath of familiar molecules. It will sift the chemistry of planet-forming disks, where ice and dust practice the ancient art of becoming home. But it starts here, with a promise kept. That if we can be patient enough to unfold a golden eye in darkness, the universe will answer with its oldest stories. We did not build a bigger eye, we learned to see what light remembers. Listen closely. Most of the universe's earliest light no longer lives where our eyes can follow. It has drifted, softened, aged. What began as fierce blue-white brilliance has been stretched thin by the breathing of space itself until it slips beyond red into warmth. That is why this telescope matters. It doesn't just look farther, it listens deeper. Give me a few minutes, and I'll show you why seeing in warmth lets us see in time. We're used to thinking of red as a color, but here, it's also a journey. As the universe expands, every wave of light is pulled longer, like ink drawn across water, like a violin note sliding down the neck until it becomes a low, patient hum. The galaxies we seek were born when everything was closer together. Their light set off in a young, crowded cosmos. But on the way to us, the very fabric between source and observer has stretched. By the time that light arrives, it has exhaled into the infrared. So if we want the first chapters of the cosmic story, we must turn our attention to where those chapters have drifted. We must look in warmth. This, too, is the realm of dust. It's not the dust beneath a bed, but the fine ash of stars. The smoke of creation, it gathers into vast cocoons, the wombs of future suns and planets. To ordinary sight, these birthplaces are curtains, opaque, stubborn, secret. Yet dust doesn't only hide, it also glows. Bathed in starlight, its grains warm ever so slightly and re-emit their energy as a gentle red whisper. In that whisper, the curtain becomes lace. Structures appear. Veins and filaments and knots of material reveal themselves. And we witness not just stars that have already burned their names into the sky, but stars still learning to speak. Infrared carries more than silhouettes. It carries testimony. Many of the universe's most important molecules, water vapor, carbon dioxide, methane, leave their fingerprints in these wavelengths. Warm dust hums, cool atmospheres ring like crystal goblets. When you split infrared light into its colors, you don't just make an image, you hear a confession. You learn what a planet's air is made of, how a newborn star feeds, how long a galaxy has been forging elements in its heart. In this language, worlds and clouds tell you who they are. To notice such faint warmth from across the abyss, your instrument must be quieter than the whisper it hopes to catch. That is why this telescope lives in a permanent night. Far from the Earth's glow, with a shield that turns sunlight into silence. Layer upon careful layer, that shield sheds heat the way a leaf sheds rain. Behind it, mirrors and sensors cool until their own warmth no longer drowns the message. You cannot listen for ancient embers if your own hands are too warm. You must become colder than space. Only then does the universe's murmur rise above your breath. Sharp sight in the long wavelengths demands more than cold. It demands size. Longer waves tend to blur unless your eye is vast and precise. So engineers built a mirror like a gold flower, many petals learning to act as one. Each segment is tuned until they sing in unison, their reflections fused into a single perfect gaze. Gold was chosen not for vanity, but for its grace in the infrared. It sends warmth faithfully onward, unscattered, unlost. A larger ear hears a softer song, and this is an ear for whispers. Even its address in space is chosen for quiet. It sits where the sun and earth balance its path, so the fiery sources of noise can remain on one side and the cosmos on the other. In that calm, temperatures stay steady, instruments stay true, and the faintest hints of far-off mornings can be recorded without smearing into guesswork. Put these pieces together, and a simple picture emerges. Early light slides toward the red as the universe expands. Dust that hides in daylight glows at night. Molecules etch their presence as patterns in warmth. To read any of it, you must become colder than your subject and broader than your doubt. Do that, and yesterday steps into focus. That is why infrared is more than a color on a chart. It is the color of memory. It is where the universe files the things it did long ago. And this telescope is not merely a bigger eye, it is a translator for what light remembers. It takes the stretched syllables of ancient events and turns them back into meaning. There is a human quiet to all of this that I love. For centuries, we trained our gaze on brightness, the blazing stars, the luminous planets, the fireworks of supernova. Now we have built a way to attend to gentler things. The embers that linger, the warmth that laces through dust, the faded glow of first structures lifting from darkness. We are learning to listen as much as we look. And there is a promise hidden in that listening. If warmth reveals what dust conceals, then the nursery doors are opening. We will watch stars take their first breaths, count the ingredients of faraway skies, and meet galaxies as they were when the universe had barely learned its own name. Not as myth, not as speculation, but as light. Light that has traveled since near the beginning, carrying its own explanations in every stretched wave. So remember this, as we begin to turn the pages. You are about to see yesterday, not by sleight of hand, not by time machine, but by a patient truth about how space works and how light keeps a record. As space grows, colors exhale. As dust glows, secrets soften. As instruments grow colder and wider and calmer, the quiet parts of the universe grow loud enough to hear. Infrared is the color of memory, and our new observatory is memory's interpreter. Now that you know why warmth reveals the past, shall we open the album together and meet the first mornings of the cosmos? Hold a grain of sand at arm's length toward the night. The patch of sky it covers is tiny, smaller than your thumbnail. Yet when the first deep field from this new telescope looked there, The darkness broke into a festival. Thousands of galaxies, each one an island of stars, some so far away their light left before the sun existed. This isn't just a pretty picture, it's a census. And by the end of this chapter, you'll be able to read it. A deep field is simple in idea and astonishing in payoff. Point steadily, collect faint light for hours, stack the whispers until the whispers become a chorus. Because the universe is vast and generous, even a pinprick of sky swells with history. Farther in space means earlier in time, so every dot, smear, and arc sings from a different chapter. Small window, and the room turns out to be a cathedral. First, learn the cast. Bright points with elegant star-shaped spikes, those are nearby stars in our own galaxy. The spikes are a fingerprint of the mirror's edges. Soft blobs without spikes, those are galaxies. Cities of suns so distant their starlight blends into a single glow. Shape hints at story. Round fuzzballs tend to be older, puffed-up spheroids. Thin ovals are disks caught at an angle. Lopsided knots can be starbursts or mergers mid-embrace. Your eye, even now, is doing what astronomers do, sorting the crowd by silhouette. Next, color without the crayon box. These images are built from several filters, each tuned to a band of infrared light. Sign the bands to visible hues, and you get a picture our eyes can parse. Redder often means older or dustier. Bluer often means a fresher blaze of starbirth, but beware. This is meaningful color, not decoration. It maps physics onto your retina, telling you who is young, who is veiled, who is ancient and dim, but determined to be seen. Now look for something stranger. Gravity turned to glass. The massive cluster in the foreground doesn't just sit there. It bends the space around it. Light passing near takes a curved path. Background galaxies are stretched and magnified into delicate arcs, sometimes even mirrored into twins. Find one arc, then hunt for its partner across the cluster. Like a cosmic spot the difference. Gravity draws with a curved ruler and sometimes writes the same galaxy twice. This is nature's own telescope, helping us spy objects too faint for any mirror alone. That bending does more than beautify, it measures. The way background shapes are sheared tells us how much mass, visible and invisible, is in the lensing cluster. From the distortions we sketch a hidden map, the dark matter scaffold that holds the cluster together. In one glance we read two stories, the foreground's weight and the background's youth layered into a single frame of time. How do we turn these impressions into ages and distances? With a little detective work. As light travels across an expanding universe, its waves stretch. The bluest notes slide into red. Astronomers use that shift as a clock. Sometimes the shift is so strong that a galaxy vanishes in the bluest filter and reappears only in redder ones. That's the dropout trick. When intergalactic hydrogen swallows the bluest light, distance leaves a fingerprint. We start with this careful, color-based estimate, then confirm with spectroscopy. Splitting the light into a barcode of lines that locks the distance in place. First we suspect, then we know. Now step back and listen to the crowd. Many small, dim, red smudges whisper of a busy dawn, when galaxies were tiny and star-making was fierce. Blue clumps betray nurseries still on fire. Smooth, mellow glows hint at elder systems that have settled down after wild youths. A single bright pinprick at a galaxy's heart can mark a growing black hole, feeding and flaring, shaping its host with winds and light. Pixels become people. People become a history. What makes this first crowd different from every deep field before? Sharpness and warmth. Earlier eyes glimpsed far galaxies, but much of the earliest starlight has been stretched beyond visible red into infrared. Dust, which once hid the cradles where stars are born, glows softly here instead of blocking the view. With the right mirror and the right chill, the shyest galaxies step into the open. We are not just seeing more, we are seeing what light remembers. If you're watching on a screen, this is where you can play astronomer. Pause. Find a spiky foreground star, the showy local. Find an arc-one of gravity's fingerprints. Find a probable merge or two smudges tugging at each other with a faint bridge of light between. Find a faint red dropout that slips away in the bluest band. There's no test and no score. There's only the quiet joy of noticing, and the way noticing turns a picture into a story. Counting the faint is more than poetry. It tests our origin tales. How many small galaxies lived at given times? How fast were they making stars? Do the numbers match the growth we expect from dark matter seeds to spirals and giants? From hydrogen fog to the metals forged in stellar furnaces? Each tiny mark on this image is a data point in that grand curve. And sometimes, the curve answers back with a surprise. More of the very young than we anticipated, or dustier cradles than our models allowed. That's how discovery looks in the 21st century. Not a single shout, but a statistical swell. There is humility here as well. Color tricks can fool. Distant dwarfs can masquerade as nearby dusty knots. That's why we return for spectra, why we check with other instruments, why the first rush of headlines is followed by the slower music of confirmation. Wonder invites us in. Patience keeps us honest. Perhaps the most human truth in this first picture is the feeling it gives you. The sense that even in the smallest window, the universe is busy beyond imagining. That feeling is not naive, it's earned. Your eye has learned to pick stars from galaxies, arcs from mirrors, youth from age, dust from daylight. You are no longer just a spectator, you've become an interpreter, hearing history in the color of light. And if a grain of sky holds a crowd like this, imagine what waits when we aim not just for beauty, but for answers. Which galaxies lit the first dawn? How swiftly did black holes grow? Where in this crowd are the seeds of spirals like our own? Those questions are not for distant committees, they are for us. For anyone willing to look long enough for the faint to become clear. We began this series of firsts with a promise. Not just new pictures, a new sense. The deep field keeps the promise. It teaches us to read the universe in whispers, to trust that a smudge can be a city, that an arc can be a lens, that absence in one band can be presence in another. It teaches us that seeing is a craft we can learn. Next, we shall step from the picture into the machine that made it. The unfolding mirror, the silver sunshield, the hush of cold that lets warm galaxies glow. If a tiny window reveals a cathedral, how did we build an eye that could open the door? Listen. For the first half-minute, as the universe holds its breath, not the loud cinematic bang we love to imagine, but a hush, the kind of quiet you hear before a choir begins. Space is young. It is cooled enough to knit protons and electrons into neutral hydrogen, and that new-made gas is everywhere like a soft fog. Light tries to travel and keeps getting sent back, scattered by the simplest atom in existence. Then, in pockets, gravity gathers the first stars. They flicker on, faint to us, fierce to their neighbors, and each one begins to burn small tunnels through the mist. Dawn is not a moment, it's a million lamps, slowly agreeing. That fog has a personality. Neutral hydrogen loves to swallow energetic blue-violet light, the kind newborn stars pour into their surroundings. Imagine throwing pebbles into a pond of thick reeds. The small ones can't make it far. Only the smoother, longer ripples slip through. Though the early cosmos worked the same way. Short, sharp wavelengths were choked. Longer, redder ones traveled. So for a time, the universe glowed in secret, bright inside little bubbles and dim between them. What changed everything were those first lamps. Clusters of massive, short-lived stars, cosmic teenagers who arrived, burned hard, and left early. Their light carried enough kick to pry electrons from hydrogen, turning fog into clear air. Around each cluster, an ionized bubble expanded. At first, the bubbles were lonely islands. Then they touched, and the borders fell away, and the archipelago became a continent of clarity. You can picture it as night lifting not from east to west, but from everywhere at once. Wherever new stars gathered enough courage to push back the dark. How do we catch that distant dawn now? We use a simple trick that every child knows from hide and seek. We look for what's missing. Hydrogen's habit of eating blue light carves a notch in a young galaxy's rainbow. Over billions of years, as space itself stretches, that missing color slides to redder and redder hues. With the right set of colored windows, filters tuned from bluer to redder, we scan the sky. A true baby galaxy will vanish in the bluer windows and suddenly appear in the redder ones. Astronomers call this a dropout. You can think of it as a cosmic peekaboo. Now you don't see me now, Shift one filter. You do. We spot the youngest galaxies by the colors they cannot keep. This isn't guesswork. When possible, we take the next step and split the light into a finer fingerprint. The notch becomes a cliff, and its precise location tells us how far the light has traveled and how young the galaxy was when it sent it. We also guard against imposters. Some faint red points are not galaxies at all, but cool stars close to home. Shape helps. Galaxies often smear into little smudges, so does color across more filters. And sometimes nature itself lends a magnifying glass. Massive foreground clusters bend and brighten background light, making the faint unmistakable. And then came the surprise, the kind a new instrument is built to find. In its first seasons, Webb revealed more bright, well-shaped candidates at very early times than many models had anticipated. Some headlines called it a crisis. It's not. It's what discovery looks like. Maybe the very first gas clouds turned starlight into chemistry more efficiently than we assumed. Perhaps early black holes grew faster and stirred their neighborhoods, prompting a rush of star birth. Maybe dust, the soot of stellar lives, appeared sooner and in stranger patterns than our textbooks predicted. The sky isn't misbehaving. It's telling us we left something beautiful out. What matters is that we can now sketch dawn as a map instead of a myth. Each young galaxy we identify is a pushpin on that map, a tiny lamp with a date attached. Where the lamps are dense, their bubbles of clear space coalesce quickly. Where they're sparse, the fog lingers. Over time, patchwork becomes panorama. There's no single-on switch, no cosmic orchestra conductor's baton, but a slow choreography of light carving corridors through a stubborn medium. Dawn is a map, not a moment. Why should any of this matter to a life lit by city street lamps and phone screens? Because the pace of that first illumination set the rhythm for everything that followed. When massive first stars exploded, they forged carbon, oxygen, iron, the alphabet of worlds and water and breath, and flung those letters into the surrounding gas. The sooner those stars lived and died, the sooner the next generation could build planets. The sooner chemistry could grow handwriting fine enough to inscribe lakes and lungs. To see the fog lift is to watch the opening paragraph of our own story take shape. There's a quiet heroism here too. Our species built a mirror that can feel the warmth of ancient starlight, a craft cold enough to hear whispers across time. We taught our instruments to notice absence, to read the edges of shadows, to find youth by the colors it cannot carry through a universe that keeps stretching the light thinner. That's not just engineering. It's patience honed into method, curiosity given an orbit. So, the next time you look up and the night feels old and settled, remember that you are seeing the end of a long negotiation between light and fog. Somewhere in those deep fields, those tiny reddish smudges are not just dots. They're first sentences, first fires, first attempts at clearing a path. They're dawn's earliest votes, cast billions of years before anyone could count them. And Webb is not done counting. Each season extends the map, tests the candidates, and tightens the story. Some contenders will fall away, others will sharpen into galaxies we can measure and model, and in time, understand. Together, they will outline a frontier that keeps stepping backward, closer to the moment when darkness first learned what it meant to be less than absolute. From here, our path is clear. If dawn revealed the room, we can now walk inside. We've seen how the fog lifts. Next, we'll cross the threshold into the workshops where stars are born. Into veils of dust that glow like embers under ash. Into cradles where gravity and turbulence sculpt suns and worlds. The universe has shown us its morning light. In the next part, we shall meet the hands that shaped it. Imagine a lighthouse so bright it drowns its own shoreline, a single point outshining the city that holds it. Now place that lighthouse in the first billion years after the Big Bang, and let its power come from darkness itself. That is a quasar, the brightest beacon in a newborn cosmos, fueled by a black hole that is still learning to eat. Stay with this paradox for a moment. The youngest skies were lit by the darkest hearts. By the end of these minutes, you'll know how we find them. Why their speed of growth is a puzzle, and how these tiny cores can set the weather for an entire galaxy. At the center of many galaxies, gas does not fall in quietly. It swirls into a hot, bright maelstrom, a disk that winds tighter and hotter the closer it gets to the point of no return. Friction and magnetic fields whip that gas to incandescence. Some of it blasts away in twin jets at nearly light speed, but much of it slips across the edge and vanishes. The light we see is the farewell glow of matter spending its last energy before crossing a horizon from which no story returns. When that banquet is rich, the core can blaze brighter than billions of suns combined. That is all a quasar needs. A hungry black hole, a ready pantry of gas, and the ruthless efficiency of gravity. Why are these early engines so intriguing? Because some of them looked too big too soon. The universe was still rubbing sleep from its eyes, and yet we already find black holes weighing millions to billions of solar masses. How did they grow so quickly on such a young clock? Can turn to dials to answer how big the seed was at birth and how fast the feast proceeded. Seeds first. One path is modest. Let the very first, very massive stars live fast and die in collapse, leaving behind black hole embers, small but numerous. Given enough time and fuel, those embers can bulk up. A second path is busier. In a packed star cluster, repeated collisions and mergers snowball into a heavier seed in the cluster's heart. And then there's the bold idea. Skip stars altogether. Let a pristine, enormous gas cloud fail to fragment into suns, and instead, collapse directly into a heavyweight seed already tens or hundreds of thousands of solar masses before the real feeding even begins. Different beginnings, right? Different growth curves. Now the feast. Young galaxies were messy and rich, rivers of cold gas pouring in along cosmic filaments, collisions between small proto-galaxies sloshing material toward their centers. A black hole in such a kitchen can dine steadily for long stretches, or binge in brief, furious episodes when fresh fuel is dumped on the stove. For a while, it may even outrun the usual limit on how fast it should grow. Enveloped by dense, trapping cocoons that let it gorge unseen from the outside. Start heavy, eat hard, or most likely do some of both. The early universe may have offered all-you-can-eat menus on every corner. But how do we know a distant glare is a quasar, and not simply a wave of newborn stars? We read the light as a fingerprint. Gas racing near a black hole moves at thousands of kilometers per second, leaves behind broad, smeared spectral lines, signatures spread wide by speed. We also see high-energy ionization marks that ordinary star nurseries struggle to produce, and a warm continuum from dust heated close to the blaze. With invisible light, dust can hide the feast. In the infrared, that same dust glows like coals, and suddenly the kitchen is visible. This is where our new observatory excels. Its instruments split that faint ancient light into colors with exquisite precision, hence separating a starburst's chorus from a quasar's solo. Sometimes the universe even lends us a magnifying glass. A massive foreground galaxy, or a whole cluster, can bend light around itself. Splitting and amplifying background quasars, arcs and mirages appear, and the tiny details of a faraway core are stretched large enough to examine. With that help, and with spectra that carry velocity, temperature, and chemistry all braided together, we can tell when we are watching a black hole dine. The story does not end at the table's edge. When a core feeds, it talks to its city. Winds howl outward. Jets tunnel through gas. Shock waves roll across spiral arms. Sometimes that outflow compresses cold clouds and triggers starbirth, like a rainstorm that knocks seeds into fertile soil. Sometimes it scours the pantry and quenches a galaxy, leaving it red and quiet. Over billions of years, a loose proportion emerges. The mass of a galaxy's central black hole tends to track the heft of the stars in its central bulge. Cause and effect do not flow in a single arrow here. It is a conversation, a long correspondence between city and heart. The smallest region of all can set the weather for millions of suns. So what can our new eye settle next? We can test the heavy seed idea by hunting for the telltale look of a direct collapse nursery. A compact dust-rich host with unusual line ratios and very few heavy elements. Too young to have been enriched by many supernovae. It can weigh the feast dial by measuring the speed and mass of outflows. It's the size of gas reservoirs. and the flicker patterns of accretion itself, how the light brightens and dims as the flow stutters. It can pair with radio and X-ray observatories to catch jets and high-energy flares in the act, setting clear, multi-wavelength timelines for how a young black hole influences its neighborhood. And when gravity's lens lends a hand, it can read details otherwise lost at distance, turning cosmic mirages into microscopes. None of this should make you feel small. It should make you feel included. If you are following this, you are reading the universe's oldest diary, alongside the people who first opened it. Your patience to sit with a paradox, too big, too soon, to hold several possibilities at once, is the same patience required to do science. You are good at this. You are helping the cosmos tell a more honest story about itself. We began with a lighthouse and a young sea of stars. Now we can see how the lamp is lit. A black hole at dinner. A disk in fury, jets and winds sending messages to a galaxy that listens. The puzzle of speed, how giants arrived so early, does not scold our models. It invites them to grow up, to make room for heavy beginnings or wilder feasts. In each new spectrum, each lens dark, each quiet whisper of warm dust is a line of evidence. A letter in a language we are finally learning to speak fluently. In the first cities of stars, the darkest hearts burn brightest. That is not a contradiction. It is the signature of a universe that wastes nothing, not even silence, when it wants to shine. Creation leaves fingerprints in dust. Galaxies have neighborhoods. These are the maternity wards, the places where darkness is warm and the quiet is busy. Stay with me for the next few minutes, and you'll learn to read those fingerprints for yourself. To spot a newborn star's first breath, to hear how light cooks the ingredients of worlds, and to see why destruction and creation share the same pair of hands. Pause at the threshold. Star begins not with a spark, but with a slowdown. In the deep cold of a giant cloud, gas drifts through a maze of long, pale threads, filaments laid down by ancient turbulence. Where those threads cross, gravity whispers stay, and matter obeys. The flow slackens, the density climbs, and a bead forms on the string. Where matter slows, stars begin. In 60 seconds, you'll be able to glance at a space image and say, that's a filament. That's where the next suns will ignite. Now, picture nearby clusters already ablaze. Your light gnaws at the cloud's face, carving columns and spires, pillars, while the densest knots huddle in their shadows. Inside each knot, the air grows thick, the temperature subtlety rises, and a core turns inward on itself. This is the cocoon stage. Quiet from outside, decisive within. If you've ever seen a pillar edged with a bright rim, you've already watched sculptor and statue at work. The pressure of starlight chiseling, the patience of gravity holding. You're reading the room like a scientist. But collapse is never a straight drop. As gas falls, it spins, and spinning things flatten. A knot becomes a disk, thin, whirling, efficient. The disk feeds a seed at the center. A protostar, not yet hot enough to shine like the sun, but gathering itself for the moment when its heart will finally fuse. There's a problem, though. Infall tries to dump too much too fast. The disk needs a release valve. So the field lines, threading it, nature's taut strings, wind up and fire. Two narrow jets erupt from the poles, drilling clean paths through the cocoon, excavating hourglass halls in the dust. Jets are the first cry, a newborn star announcing itself to the dark. In half a minute, you'll know how to spot those cries and what their knots and beads are telling you. Look for paired streams pointing in opposite directions, dotted with little shocks along their length. Each knot is a heartbeat, a brief surge in the flow. It's evidence that even celestial births are a little messy, a little stop and go. The jets do more than vent. They clear the way for light to escape and for us to peek in without blinding glare. When you see an hourglass cavity, you're looking down the first tunnel a star dug to meet the universe it will one day light. Meanwhile, chemistry gets to work in the shadows. Dust grains, tiny stubborn specks of carbon and silicate, collect thin coats of ice, water clings, carbon dioxide, methane, and more. Settle into frosts. Those coatings meet in gentle collisions, stick, and grow. The disk becomes a kitchen, its shelves stocked with ices where it is cold, and vapors where it is warm. Move outward, and you cross snow lines, rings where particular ices can survive. Beyond the waterline, worlds can hoard oceans. Inward, rocks bake and build continents. Starlight cooks, dust remembers. In the next minute, we'll turn that poetry into a skill. You'll learn what the colors of warm and cold actually say. Warm dust glows at longer wavelengths than the light your eye can see. When an instrument reads that glow, it isn't guessing. Measuring the temperature of the flour and the spice, the water and the salt. Where the spectrum shouts water, you've found a cool, shielded zone. Where it flashes with signs of ionized gas, you've wandered near fierce neighbors. By splitting light, we turn a picture into a diary. Not just what is there, but what it's doing. Now step back and watch the neighborhood breathe. Young stars do not arrive quietly. They push. Winds stream from their surfaces. Their light ionizes the gas, blowing great bubbles that grow and merge. When those expanding fronts press on the surrounding cloud, they can ring it tighter, squeezing new beads along the filaments, triggering the next round of births. But if the winds scour too hard, if the bubbles overlap and the pantry thins, star-making can stall. Quench, kindle, quench again in stellar cities. Creation and cleanup are the same crew. In a few moments, we'll connect that breath, the push and pull, to the ingredients of life and the metals in your blood. Inside the newborn fusion lights, hydrogen into helium. Later, in heavier hearts, helium into carbon, oxygen, and beyond. Stars are tidy accountants. They track what flows in and what flows out. Some, in their old age, exhale carbon-rich winds that drift like soft ash into space. Others end loudly, supernova returning iron and calcium to the common pool. Every planet that cools from that enriched dust inherits a chemistry kit, and with it, a wider chance for complexity. The oxygen in your lungs, the calcium in your bones, the iron in your blood, all receipts from furnaces that burned long before our sun was born. This is not just astrophysics, it is family history. Let's turn what you've learned into a simple reading guide you can carry anywhere. See a long, dim thread. That's gravity's net, the place where matter slows. Spot a pillar with a bright edge. That's erosion finding resistance, carving around a stubborn core. Notice a thin hourglass, a matched pair of streams dotted with knots. Star has cried out, and if the colors lean warm in the spectrum, dust is glowing nearby. If cool lines whisper of water and carbon compounds, you've discovered a pantry for planets. You don't need to memorize terms. Just remember the story. Gather, spin, vent, light, season, breathe. You can read the sky. There's one more twist worth your time. Birth changes the neighborhood, and the neighborhood changes birth. Jets carve holes that let radiation reach deeper. Radiation erodes surfaces that reveal new cores. Supernovas seed the next clouds with heavy atoms that cool gas faster, speeding collapse. This feedback is not an afterthought. It is the plot. When you stop counting grains, dunes begin to speak. And here, when you step back from atoms and lines, whole regions tell you how they are raising their young. If you're still with me, you've done something that matters. You've not only learned new facts, you've learned a way to look. You can now hold a galactic nursery like a map and say where the roads run, where the villages form, where the next towns will rise. That kind of seeing takes patience, and you have it. That kind of listening takes care, and you've shown it. You're good at this. Before we go, tuck away a little confidence. The next time you pause on an image of pillars or filaments, don't just admire, translate. Ask, where did matter slow? Where did spin flatten? Where did jets cut? Where did light cook? If you can answer even one of those, you're already part of the conversation the universe is having with itself. Creation leaves fingerprints in dust. Today, you learn to match them. And there's a reason to keep learning. These cradles raise not only stars, but worlds. From the hourglass of a single jet to the shine of an entire disk, the next chapter gathers around those newborn suns like fireflies. We've learned how stars are made. Next, we shall meet the worlds that gather around them and taste the air of distant skies. In the very next part, we shall walk out of the nursery and into the weather, reading the colors of alien atmospheres and hearing the first hints of storms on worlds we've never seen. Tonight, we write a weather report for a world we will never visit. A pinprick of starlight dims by less than a whisper. And yet, folded inside that dimming is a skyline. Rivers of vapor, towers of cloud, winds that run faster than storms on Earth. Give us one good transit, one patient spectrum, and we can tell you whether a planet's sky is clear, hazy, or heavy with water. By the end of these minutes, you'll be able to read the first lines of that forecast yourself. Picture a small planet sliding in front of its star. Round the planet, a thin rim of air glows like a halo. Starlight threads through that rim on its way to us. Certain colors are nibbled away, so precisely that each gas leaves a signature. Water dips here. Carbon dioxide presses there. Methane hollows out a band of its own. What reaches our telescope is not just dimmer starlight. It's edited starlight, annotated by an atmosphere. There are 3 ways we listen to a distant world. First, during the transit, when the planet crosses the star, we look for those missing colors. This is transmission, the stained glass method. The atmosphere backlit becomes a barcode. Second, during the secondary eclipse, when the planet slips behind the star hides the planet's own glow for a moment. The tiny drop in total light is the planet's thermal fingerprint. That's emission, a whisper of heat. Third, all along the orbit, the planet shows us different faces. Bright day, cool night, the shifting in between. Track that rhythmic change and you get a phase curve, a light curve map of climate in motion. With those 3 listening modes, stained glass, missing heat, and rhythm, we turn a flicker into a forecast. Open a spectrum, and you'll notice its terrain. Broad arch here, often water vapor, telling us about humidity and altitude. A deep, symmetric valley there, carbon dioxide, a precise barometer for temperature structure, a knuckled set of features, methane or ammonia, depending on heat and chemistry. Even a non-feature speaks. If the spectrum is flat where you expect hills, it can mean clouds or hazes are muting the view. A veil of droplets or soot grains blurring sharp lines into a soft tilt. And here's the part that always feels like a quiet miracle. If you've followed this so far, you have already read your first exoplanet atmosphere. You can look at that forest of lines and know what to call the trees. Hot Jupiters, gas giants skimming their stars, are the loudest teachers. Their daysides blaze like forges. Their nightsides cool to ember. The hottest spot is often pushed eastward from where you'd expect it, evidence of supersonic winds hauling heat downstream. Some are so hot that common molecules tear apart by day and knit themselves back together by night. A chemical tide that runs on a 24-hour heartbeat fixed by the orbit. Follow the brightness through the orbit and you can sketch a crude map. A hotter hemisphere here, cool crescent there, a jet stream shifting the peak glow away from noon. A planet that was once a point on a slide now has weather. Beyond the roaring giant's weight, the subtler prizes. Warm sub-Neptunes and super-Earths. Around small, steady stars, their signals grow larger. But smaller stars can also be freckled with spots and flares. Their own changes can masquerade as air. So we compare many transits, catch the star in different moods, and tease apart planet from parent. When we claim water vapor or methane on a small world, we make that claim with humility. This depth, this color across these visits, after this many cross-checks. You'll hear people speak of biosignatures, pairs of gases that shouldn't coexist unless something is busy replenishing them. That's a beautiful idea, and one we approach with care. Planets can fake us out. Harsh ultraviolet light can split water and leave oxygen behind without a single leaf to help. Volcanic gases can mimic the breath of life. So the rule is simple and strong. Context first. Surface, star, season, and sibling worlds nearby. Everything matters. That's not a disappointment. That's how a field grows honest. How do we go from a squiggly spectrum to a sentence like high clouds, water vapor, modest methane? We run what scientists call retrievals. Imagine a library of possible atmospheres. Different temperatures, cloud heights, compositions. We let the computer try them on, one after another, and we keep the few that match the data best. Where several very different atmospheres fit equally well, we say so. Uncertainty isn't the enemy of truth. It's the sign that truth is still generous, still leaving room for more light. Think of a spectrum this way. It's a question asked in color. Every dip and rise is the answer to what do you keep? What do you throw away? The echo of a world's chemistry choosing, line by line. When a planet disappears behind its star, we catch its heat alone for a heartbeat. Repeat that trick at many wavelengths and you can tell whether the day side is a sea of cloud or a window onto deep hot layers. Watch the peak brightness slide east or west through the orbit and you can estimate the wind. How far a hotspot is carried before it cools. Add many orbits together and a picture emerges. Weather, not just climate. We're still at the sketching stage, but you can already feel the brush gaining confidence. Longer, staring, patient, repeated visits turns hints into maps. We'll seek smaller, cooler planets where molecules don't burn away and clouds don't drown the signal. We'll pair space telescopes that love the infrared with ground-based giants that can measure the tiniest shifts in color caused by winds themselves. One day, with steadier stars and steady hands, we may even watch a season change on a world whose sun is not our own. And as those data sets grow, so does something in you. Your ear for spectra, your sense of what a flat line means. Your caution around life as a headline, these are the muscles of scientific listening. You're not a spectator here. You're learning the grammar as it's being written. Hold this single sentence as a compass. To know a world, listen to the way it edits starlight. The rest, the acronyms, the instruments, the catalog numbers, is scaffolding. The heart of it is light altered by air, arriving across impossible distances to say, I passed through a sky, is what that sky kept, and here's what it let go. We began with a promise. A weather report for a place we'll never stand. Now you can hear the forecast in the spectrum's sway. The water arch, the carbon shoulder, the haze that flattens the view, the wind that drags a hotspot east. You can tell when to be excited and when to be cautious. That balance, that gentle resolve, is how discovery lasts. Next, we shall lift from single skies to the wider neighborhoods that shape them. How families of planets arrange themselves, and what patterns whisper about the way solar systems are made. But for a moment, let's stay here with this one quiet miracle. A distant world, speaking in stolen colors, and a species on a small blue dot that has learned to listen. Before there were recipes, the universe learned flavors, not in kitchens, but in the cold. Around young suns, a thin, dusky disk turns in near silence. Gas and dust circling like flour in a shallow bowl. Look into that darkness, and you are peering into a pantry. Grains brush against grains, cling and grow. Pebbles become boulders, boulders become seeds of worlds. What decides whether those worlds begin parched or blue, barren or fragrant, is written here in the dark, where light is scarce but chemistry is busy. Picture the disk as a patient workshop. Gravity gathers, friction kneads, and time bakes. Rings and gaps are not ornaments. They are traffic lanes and waiting rooms. In certain rings, pressure traps slow the drift of pebbles, letting them linger long enough to stick and thicken. Elsewhere, gaps hint that a newborn planet is already sweeping its orbit clean, like a broom cut from stone. In this bustle, temperature falls with distance, and that single fact turns vapor into frost, and frost into destiny. We call the boundaries snow lines. They aren't white and fluffy. They are invisible thresholds where a gas freezes to ice. Closest to the star, everything is too warm and most molecules remain vapor. Farther out, water crosses its line and coats grains with slick shells. Step still farther, and carbon dioxide freezes. Beyond that, even carbon monoxide settles into frost. Each line changes the game. Ice-coated grains are stickier, more eager to merge, and they carry with them the very substances that will one day steam in clouds or pour as rain. Cross one line, and you bias a future toward oceans. Cross another, and you tilt the sky toward carbon haze. A snow line is where cold turns breath to stone. How do we know what's hiding in the dark? Because even darkness glows if you listen for the right notes. Warm dust hums softly. Ices and gases imprint their favorite vibrations on faint infrared light. Read those fingerprints, and a list emerges. Not life, not even recipes. but ingredients and kitchen rules. In those lists, we now see water as vapor near the warm inner lanes and as ice in the cold mid-plane. We see carbon dioxide and carbon monoxide tracing where carbon will end up in rocks, in air, in frost. We see methane and ammonia, hydrogen cyanide and acetylene, methanol and simple aldehydes. Small molecules that in laboratories on Earth take first steps toward sugars and amino acid precursors. Up in the surface layers, starlight scuffs the grains and paints them with aromatic rings, the faint signatures of carbon skeletons called pause. It is a lively place, this quiet disk. Ultraviolet light breaks molecules apart in one layer, and shadows below invite them to reassemble in new, more elaborate forms. Life's cookbook begins as smudged notes in ice. If this sounds like romance, remember, the romance has rules. Temperature, pressure, and radiation sort the disk into neighborhoods. In the upper skin, light is harsh. Chemistry is quick and messy. Deeper down, the midplane is cold and protected. The pantry, where ices accumulate, where pebbles hoard their cargo and quietly drift inward. Turbulence ties the layers together. Eddies mix flavors across snow lines, and every orbit brings another chance for dust to collide and cling. When you stop counting grains, dunes begin to speak. Delivery matters. Ingredients do not stay where they form. Pebbles load themselves with ice and organics beyond the waterline, then spiral inward under the faint drag of gas, like raindrops swept on a slow wind. Growing planetary cores meet them like open hands. This is pebble accretion, an efficient way to feed a world from a disk's outer shelves. Later, when the scaffolding of planets is set, the couriers become larger. Comets and icy fragments scattered inward by giant planets. They crash, crack, and vaporize, spilling water and organics onto young crusts. Oceans may be the memory of comets. All the while, chemistry keeps a ledger. The ratio of carbon to oxygen in the material a planet swallows, the CO balance quietly leans its personality. More oxygen, and you favor water, rock, and familiar weather. It's more carbon, and the atmosphere can grow hydrocarbon-rich and alien. With clouds of soot and skies that burn the color of copper, even the rocks reflect this balance. Whether mountains turn to clays or to carbides, whether rain weathers stone gently, or fights to fall at all. The temperament of a world is written by what it eats. None of this is hype, and none of it is guesswork without anchors. The lines we trace in infrared are particular. Water's broad, rounded shoulders. Carbon monoxide's clean, narrow marks. The subtle bends of methanol and ammonia. In some disks, we can separate the glow of the warm inner lanes, where rock and metal gather, from the whisper of the outer freezer, where giant planets and comets take shape. In others, we watch the same molecule in gas and ice, a diptych of phase and place that turns a model into a map. Chemistry in the dark is no longer a rumor, it's a ledger we can finally read. If you followed this far, you are doing more than watching a film. You are learning to hear. You're reading spectra the way a chef reads a market. Not as a list of nouns, but as a promise of meals. You now know why rings and gaps matter, how snow lines sort futures, how pebbles and comets move taste from shelf to stove. That is a quiet kind of power, to look into a silhouette and name what will boil, what will rain, and what will settle into stone. There is humility here, too. We cannot yet say which disks will grow blue marbles and which will grow copper skies. We are still learning how turbulence stirs, how often giants migrate, how often delivery floods a young surface or misses it entirely. But the direction is clear. Creation leaves fingerprints in dust, and we at last have the fingertips to feel them. Remember the line that opened this chapter? Before there were recipes, the universe learned flavors. In the glow beyond sight, in rings that sift and lanes that feed. Those flavors are mixed and moved, frozen and thawed, broken and made new. A world is a memory of its pantry. And with every spectrum we collect, we inch closer to tasting from across light years what a place might one day call rain. Across 1 million miles of cold space, a single ancient photon lands on a quiet sensor. In that instant, we do not celebrate a pretty picture. we make a promise. This speck of light will be treated with care. Translated, tested, and asked to tell the truth. Wonder is a feeling. Science is the discipline that lets it last. Think of the observatory as a small orchestra with 3 lead instruments. First, the imagers. Wide, steady eyes that sketch the shapes of faint things and show us where to look. Second, the spectrographs, patient ears that split light into a barcode of colors, letting chemistry, temperature, and motion speak. Third, the cornographs, polite sunglasses that hush a blinding star, so the whispers around it, planets, dust, delicate rings can come through. Pictures tell us where. Spectra tell us what and how. But before any melody becomes music, there is tuning. Raw starlight arrives tangled with the instrument's own heartbeat, so we begin with a ritual of calibration. We measure darkness itself to learn the camera's faint internal glow and subtract it away. We take flat images of uniform fields to reveal which pixels are a touch too eager and which are shy, then we even them out. We nudge the telescope by tiny amounts so that a flaw in one pixel is averaged into silence by its neighbors. We observe trusted standard stars so each color lands exactly where it should. Only then do the counts become colors, and the colors become meaning. Before truth, we clean the mirror. This care does not fight wonder, it protects it. A deep field is glorious, but it grows more glorious when we can say, not just what we see, but how well we know it. The little bars on a plot, those error bars so many scroll past, are not apologies. They are honesty made visible to tell you how hard the team listened. One observatory rarely carries a claim alone. We cross-check. If an imager hints at a hidden arc, a spectrograph asks whether the chemistry matches that distance. If the spectrum sings of water in an alien sky, we look again on another day to see if the song repeats. We compare with ground-based telescopes, with radio arrays, with X-ray eyes. When different senses agree, the story thickens into fact. Headlines often arrive in bright colors, then soften as calibrations improve. That is not retreat. That is refinement, the world coming into focus as the noise clears. Meanwhile, the observatory itself is alive, and living things learn. Mirror segments are nudged by hair widths to remain in perfect chorus. Cryogenic coolers hum to keep mid-infrared vision honest. Micrometeoroids tap the gold tiles from time to time. Team listens, adjusts, and the music continues. Precision is not a setting, it's a practice. The more patiently we tend the instrument, the more patiently the universe speaks back. You might wonder who decides what the telescope does with its precious time. Ideas do. Scientists from around the world write proposals that say, here's a question worth the dark. Panels weigh those questions, and time is awarded not to names, but to the sharpness of the inquiry. And here's the part that matters to everyone. After an initial period for the teams who collected it, the data go to a public library in the sky. Students, citizen scientists, curious minds, anyone can learn the grammar of the light. Truth grows by being shared. From click to count to knowledge, there are 1,000 small choices, each designed to prefer reality over our hopes. We clip cosmic ray streaks we didn't ask for. We model the glow of backgrounds we cannot escape. We write software to repeat these steps with the same steady hand every time, and we publish the code so others can check our work. When fresh calibrations arrive, we re-reduce old data and sometimes find that yesterday's possibly becomes today's likely, or that likely becomes almost certain. This humility is not weakness, it is strength. It is how we keep our promises to that first photon. If you've ever taken 2 photos of the same scene and adjusted the white balance until the snow looked like snow, you already understand a piece of this art. If you've ever waited for a rumor to become a report and a report to become a result, you already think like a scientist. Your patience is not passive. It is participation. By giving careful stories your attention, you help the careful stories win. All of this, eyes, ears, sunglasses, tuning, cross-checks, open archives, is what turns a beautiful image into a durable insight. We do not ask the universe for thunder. We ask for clarity. Clarity takes work. Long nights of calibration, quiet revisions, friendly arguments that end in better answers. The miracle is not that we sometimes make mistakes. It's that we have built a culture that knows how to notice and to mend. So the next time a headline claims a world with clouds or a galaxy seen at a staggering age, imagine the path behind those words. A photon left a place you will never visit and crossed a wilderness of time. It struck a sensor colder than Arctic winter. It was counted, cleaned, compared, and invited to testify alongside a choir of other photons. Together they became a spectrum, and the spectrum became a sentence the cosmos could understand us reading aloud. Wonder is a feeling. Science is the discipline that lets it last. The instruments steady and the methods honest, we can step back and hear the larger composition they are all playing. The notes are scattered across space and time, but the theme is simple. When we are careful with light, light is generous with truth. We built a new sense for the night, an eye that drinks warmth and time, and it has already whispered where to look next. In the next few minutes, we won't relive first images. We'll map first steps. Who will scout, who will zoom, and which questions are finally close enough to touch. Stay with this, because the most beautiful thing about a new sense is the way it teaches all the others to sing. No telescope, however glorious, can finish the story alone. The sky rewards ensembles. Wide field missions will sweep the stage. Euclid and soon, Roman will chart vast tracts of cosmic structure, where gravity gathers and where it thins, flagging the rare lenses and ancient clusters that deserve a closer listen. On the ground, the Rubin Observatory will film the night, catching transients as they flare and fade, supernova, tidal disruptions, kilonova embers. And when the alert arrives, our gold mirror can swing, not as a tourist, but as a surgeon splitting faint light into meaning. Cold matter translators join the choir. Rays like Alma and Noema weigh the chilled gas and dust, the raw ingredients of stars and planets. While our infrared eye reads the warmer chemistry, those ingredients ignite. Farther back in time, low-frequency radio arrays will map the soft 21-centimeter hush of neutral hydrogen, sketching the fog of the early universe. Against that map, we can place the first lamps. Young galaxies, our spectra, already reveal, pinning down who lit the darkness and when. And on the horizon, giant ground telescopes, the ELT, GMT, TMT, will add razor-sharp, high-dispersion vision. They will listen for the tiny tugs and subtle lines in the atmospheres of smaller, cooler worlds, while our spaceborne mirror builds the broad, deep context. A single masterpiece is lovely. A symphony makes history. In 60 seconds, 3 frontier questions this orchestra can help settle. The earliest stars were engines without metal, hydrogen, and helium forged in the Big Bang. Nothing more. Their births and deaths wrote the first edits in the cosmic recipe. What should we look for? Galaxies with almost no heavy elements. Peculiar supernova yields, ashes that tell of unusual furnaces. Helium lines where you wouldn't expect them. Patchy regions where the early fog of neutral hydrogen thins first and last. Each clue tightens a timeline. Who lit the fog? How many? How fast? Closer to home, though still unimaginably far, the atmospheres of sub-Neptunes and super-Earths, the cautious edge of truly rocky, temperate planets around quiet red dwarfs. We can read water vapor, it's carbon dioxide, methane, and the shapes of clouds and hazes. We can measure day-to-night contrasts, winds, and seasons on hot giants. Then slide towards smaller, gentler worlds with help from future instruments. This is not the promise of biosignatures tomorrow. It is the promise of clear steps today. In protoplanetary disks, snow lines divide water from rock, organics from ice. Rings and gaps betray hidden planets, shepherding pebbles into paths. By pairing chemistry from space with motion from the ground, we can see not just where planets are likely, but how often worlds like ours have a chance to form. The blueprint of many solar systems is finally legible. Headlines glow and fade. Truth accumulates. It takes mirror tuning and calibration. It takes the quiet, unglamorous care to correct tiny biases and measure the same star on different nights the same way. It takes patience when micrometeoroids tap the mirror, and skill when engineers reshape the wavefront by fractions of a wavelength to keep the image sharp. If you have learned to sit with uncertainty for a while to ask how do we know, before you ask what does it mean, you already think like a scientist. That patience is the secret fuel that turns astonishment into understanding. You are not outside this story. The doors are open. Public archives let anyone browse raw skies. Community tools let you pull spectra, adjust stretches, try your own color maps. Citizen science projects need careful eyes to tag lenses, spot moving dots, and classify disk structures. And with a minute of image literacy, you can read more of the night yourself. Diffraction spikes. They mark bright stars in the foreground. Don't mistake them for a galaxy's arms. Smooth fuzz, often redder, likely a galaxy's light stretched by time and dust. Arcs that seem too graceful to be true. Gravity's mirages, the universe lending us a magnifying glass. And remember, colors in space images are translations, labels that show which filters you're seeing. Check the legend. You're learning the dictionary the cosmos uses to talk to us. Curiosity isn't a spectator sport, it's a membership. Every careful glance, every note you make about a curious arc or odd spectrum is a stitch in a shared fabric of knowing. Put it together. The scouts, the surgeons, the translators, the giant sandopath appears. We will bound the timeline of cosmic dawn with real fingerprints, not guesses. We will turn the blur of small exoplanets into a map of climates, clouds, and chemistry, one world at a time. We will witness disks feeding planets and planets sculpting disks, tracing the odds that rivers and continents arise at all. And when collisions shake space, when neutron stars merge and heavy elements are minted, alerts will fly. Infrared eyes will take spectra of the cooling glow, and we will see gold and platinum being born. This is how a new sense matures. Starts with beauty, then learns discipline, then offers courage. The courage to look longer, to be delighted by being wrong, to be changed by the sky. We began with a new eye that taught us where to look. We end with a decade of handoffs, answers, and better questions. Keep this sense sharp. The night is younger than we thought. First light is only the first chapter. The gold mirror that once slept, folded like a secret, now stands open to the night. It drinks an ancient light, listens to the low music of dust and dawn, and returns to us stories we were born from but had never heard. We set a mirror toward yesterday and, in its depth, we met ourselves. Written in starlight, carbon from elderly suns, oxygen from exploding hearts, iron forged where gravity closes its fist. We did not bring the morning to the universe, taught ourselves how to greet it. The first pictures were not trophies, but invitations. Each galaxy a sentence, each spectrum a verb, each faint smear a child of time whispering, "Read me." What began as an unfolding in silence became an unfolding of history and of memory and of us. Tonight, if wonder found you, it's because you already carry the instrument that matters most. The quiet attention that turns noise into meaning, your patience with paradox, your willingness to linger on a single speck of sky and imagine the multitudes hiding there. These are not small acts. They are the very gestures by which knowledge lasts. To the engineers who coaxed gold into a compass, to the teams who tune a heartbeat of photons into truth, to the patient craft of calibration and caution, we owe more than thanks. We owe a future of careful listening. And to you, thank you for your time, the rarest gift. Thank you for lending your eyes and your minutes to a story measured in billions of years. You made room for the universe to speak. What comes next is not an ending, but a widening. Cooler worlds will step out of glare, their skies etched with water and wind. Earlier embers will surface, the first lamps that melted the cosmic fog. Chemistry will gather in rings and snow lines, and somewhere a small planet will edit starlight in a way that feels like a hello. First light is only the first chapter. The table of contents runs on ahead of us, bright and generous. If a single image tonight lingered in your mind, keep it, share it, return to it when the world feels narrow. The same elements that colored those distant clouds also color your breath. You are not outside this story. You're a page it learned to write on. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. Till next time, keep asking, keep looking up, and never stop wondering.